Okay, so in this video, we're going to continue studying the quadratic function. In this case, we're going to study what are the maximum and minimum values of a function. Right? As you can see, this parabola, this is the graph of a quadratic function. If the parabola opens up, that means that a is greater than 0. We have that this is going to be a minimum value. Why a minimum value? Because everything else is going to be on top of that value. It's going to be more than this value right here. Now, if the parabola opens down, that means that we have a maximum value. Because again, everything here is going to be below this value, every other value right there. That maximum and minimum value is going to be x equals to negative b over 2a. That's, remember, I had to find the vertex. Now, if we substitute that value here, that's going to be my minimum value. So it's actually the k value, right? Remember that we have h and k are the vertex. So k is my minimum or maximum value. The domain, as we already saw in class, for a quadratic function is always all real numbers. And the range is going to be greater than this same value. So this value right here, this value is the same as k. And this is the same, right? This is the same as k. Over here, the same. So this same value, so y greater than, because again, this is my minimum value. So that means that every other value has to be more than that one. If it's a less than 0, so that means that a is negative, that's going to be a maximum. So my range is going to be less than or equal to that number right there. My graph is going to be, if a is greater than 0, it's going to be decreasing on the right until that point right there. And then it's going to be increasing on the right, sorry, decreasing on the left, increasing on the right. And the change or the critical point is that same value. Now, the decreasing and increasing, we're going to write it with x. So this is the same as the h value. The h value. Right? This is the same as the h value, if you remember from that lesson, last lesson. Right? So let's find the minimum or maximum values of each function, describe the domain, range, and where the function is increasing or decreasing. Again, on this case, I'm going to start by identifying that a equals to -2, right? And b is 6. In this case, for now, when I'm identifying this, I don't need c. So x equals to the opposite of b divided by 2 times a. So that means that this is -6 divided by -4. So that means that this is the same as 3/2. I'm simplifying by 2. Right? So now I'm going to find f of 3/2 equals -2 3/2 squared plus 6 times 3/2 minus 1. Okay, so this is the same as -2. This is the same as 3 squared divided by 2 squared, so 9 over 4 plus 18 over 2 minus 1. Right? I can multiply here. I got -18 over, actually I can, let's do it another way. I can simplify this 2 with this 4. So this is going to be a 2 here. So I got -2, -9 over 2 plus 18 over 2. And as you can see, my common denominator there is 2. So I'm going to change this. Remember that we have a 1 here. So I got to multiply this denominator times 2 and this one times 2, so I can convert that fraction and I'm able to subtract. So 2, so minus 2 over 2. So that means that I get -9 plus 18 is 9. 9 minus 2 is 7 over 2. So that means that my vertex on this case is 3/2 and 7 over 2. Because a is a negative value, that means that the function, this graph is going to open down. So that means that we have a maximum value at y equals 7 over 2. Remember that this same value from here, right? The domain, again, is all real numbers. Then my range, if that's the maximum, that means that y is going to be less than or equal to 7 over 2, because if this is the max value, everything else has to be less than that. Then we're going to determine where it's increasing and decreasing. So again, because it's negative, that means that it's increasing to the left of, so increasing to the left of x equals to 3/2 and decreasing to the right of x equals to 3/2. Again, this value that is here is this one that we're finding. Okay, let's see the next one. Again, let's start by identifying. So A. Now letter B, again, let's identify A first. So 1/2. B is 7. So x is going to be the opposite of b, so -7 divided by 2 times 1/2. We know that 2 times 1/2, that's the same as 1. So that means that I got that x equals to -7. I'm going to find f of -7. So that means that I get 1/2 times -7 squared plus 7 times -7 plus 3. So I got 1/2 of 49 minus 49 plus 3. So that's the same as 49 over 2 minus 98 over 2 plus 6 over 2, right? Remember that this has a 1 down here, so that means that I got to multiply times 2 to be able to subtract and add those numbers. So 49 minus 98 plus 6, that is 43 over 2, or -43 over 2. So -43 over 2. Okay, so that means that right here, get A is positive, so that means that this has a minimum value at y equals to -43 over 2. Okay. Domain, again, is all real numbers. Range, this is the minimum, so that means that y is going to be greater than or equal to -43 over 2. Right? It's increase, or actually it's decrease to the left of x equals to -7, and it increased to the right of x equals to -7. Okay, so letter C, again, let's start identifying A equals to 3, B equals to -6. So again, my function is going to be x equals to the opposite of b, so +6 divided by 2 times 3. So 6 divided by 6 equals to 1. Now I'm going to find f of 1. So 3 times 1 squared minus 6 times 1 plus 4. So this is 1. So I got 3 minus 6 plus 4. So I get -3 plus 4 is the same as -1. Sorry, +1, right? +1. Let's fix that, +1. So again, this is positive, right? A is positive, so that means that it has a minimum value, a minimum value at y equals 1. Domain, again, is all real numbers. Range is y greater than or equal to 1, and it decreased to the left of x equals to 1, and that one is this one over here, and it increased to the right of x equals to 1. And that's it for this lesson. May the force be with you.